Hi, hello friends, welcome to the today's session and welcome to Unacademy. In this session, we are going to continue the balanced search trees. The last session, we learned about one of the balanced search tree called as a B tree. Now in this session, we are going to discuss about the second part of your balanced search tree, nothing but B plus tree. So before going into the discussion, let us say our anthem that crack GATE and ESE with India's largest learning platform and none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. You all know Unacademy is playing vital role to provide online content to all corners of India. So, my dear friends, wherever you are, Unacademy follows you and see that Unacademy is also going to provide a top quality in-depth training in your own respective field. So my dear friends, what you need to do to achieve that, just you take the subscription, then you're going to get unlimited access and unrestricted access to Unacademy portal. So whatever are there in Unacademy portal, you can able to access them. And myself is Srinivasrao IS, having more than 15 years of experience in the various subjects of computer science. I also had industry experience in systems side as well as database side. Also had a good certifications according to my expertise. So my dear friends, you also can achieve this. You're all going to get this kind of a guidance too once you get admission in an academy. I taught in many premium academies with a high success rate. Many of my students completed their post graduation in premium institutions and they are working in the topmost positions in topmost companies. And many of my students are also acting as a gate mentors. So you also can able to see such kind of wonderful life in the rest. Therefore, my dear friends, you take a subscription in an academy and get it benefited out of that. Unacademy is providing two kinds of subscriptions, 12 months and 24 months. So current fourth year students can opt for this 12-month subscription. 24-month subscription can opt by third year and second year and first year students. So my dear friends, you start your GATE training as early as possible because this GATE training is going to be helpful in your regular curriculum subjects like CNDS and data structures, as well as algorithms and TOC compiler design, database, computer networks, operating system, whatnot. All subjects you could able to have a good grip on that. Apart from that top quality content, Unacademy is also offering a maximized discount by applying my referral code. So use my referral code and get the maximum benefit out of that. So my dear friends, so Unacademy is providing an online platform. It is going to act as an interface between the faculty member and students too. So please enjoy the benefits and enjoy the course content which are providing by Unacademy. So let's crack Gate CSC is our YouTube channel. Please subscribe that and use my referral code to get the maximized discount. Hit the bell icon for latest notifications and updates. My dear friends, please be serious towards your goal. You want to achieve the goal, there is a need of a proper training. That training you're going to be get provided by Unacademy faculty members. Now, today I'm going to presenting you the second part of your balanced research trees. The last session we discussed that one of your balanced research tree is nothing but B tree, which has got its own pros as well as the cons. So what are its advantages and what are its disadvantages? Advantages is a superb, but what is the disadvantage? The record pointers are available at all the levels of the tree. That is only the drawback in this. Apart from that, it's a ultimate tree, especially which is acting in a multi-level, dynamic multi-level indexing. So what is the concept, my dear friend? The structure of a leaf node as the same like your root and internal node, especially in B tree. And one more thing, because of that assumption, record pointers or data pointers or information pointers are available at all the levels of the tree. That means you will find the record pointer in leaf level and root level as well as internal node level. This is one of the problem of your B tree. Therefore, you see that overhead in the respective blocks, especially root and internal node, by maintaining what I mean to say a record pointer. These problems can be eliminated using the concept of B plus tree. What is the power of your B tree apart from other facilities? It is also going to say that the keys are not going to be duplicated. And what are the drawbacks? Overhead, I say one of the drawback because of maintaining a record pointer. Therefore, you want to reduce the overhead, then you're supposed to use the concept of a B plus tree. So the overhead, because of this, record pointers are existed at every level of your tree. My dear friends, be ready to learn your B plus tree. So what are the B tree constraints? We have seen the B tree constraints are nothing but a root is going to start with a one node and can have m children, as well as a minimum you need to sustain two children pointers. Internal node is supposed to maintain minimum block factor and maximum block factor. Minimum block factor is T log m by 2 and maximum block factor is m. These many pointers you can able to maintain. And the leaf node is supposed to have maximum m minus 1 keys and minimum m by 2 minus 1 keys. So my dear friends, that's why it is a concept called as half full and complete full. Half full is nothing but 50% and complete full is nothing but 100%. Now let us see. We already discussed the equation of your B tree such that every block is supposed to maintain three important nodes, information about nodes, that is m block pointers and m minus 1 keys and m minus 1 record pointers. So you need to maintain them in a single block. That's why because of this there is a much overhead. I cannot able to maintain much degree. So you want to have a much degree, then you're supposed to use the concept of a B plus tree. Therefore, my dear friends, how are you going to calculate the degree? I will show you in this example. So when you are talking about, for example, he is asking find degree of B tree. Find degree of B tree. So whenever he is asking find degree of B tree, he is asking indirectly m value. What is the meaning of m? Maximum number of block pointers. So that's the meaning of m, maximum number of tree pointers, also called as a child pointers, also called as a block pointers. How are you going to get? Using a small equation what we discussed in the last slide. If I am saying block size is a 512 bytes and index size is a 15 bytes, and I am saying that record pointer size if I am saying something like a 7 bytes, so let me give you a bit lesser to this, it is a 9 bytes. And if I am saying that your block pointer size is a 7 bytes, now he is asking find the degree of B tree or order of B tree. A degree of B tree. So we know the equation. What is that equation? M block pointers, m minus 1 search keys, m block pointers m minus 1 search keys and m minus 1 record pointers are supposed to be placed in your block. So according to that, he mentioned the block size is a 512 bytes. M value we don't know, we need to find M value, and block pointer size is mentioned as a 7 bytes, and M minus 1 key size is given as, look at this, key size is given as 9 bytes, and M minus 1 record pointer size is also mentioned as your 7 bytes. So after posting that, you do the calculation part. What is the calculation part? All are in bytes only. So all are in bytes representation. Let me take the numericals. So M7 plus 9M minus 9 and plus 7M minus 7 is equal to 512. My dear friends, so 16M plus 7, 23M is equal to 528, because 9 plus 7 is 16, 16 plus 12 it is a 528. So M is equal to 528 divided by 23. This is your value according to B tree. So you have got found what is the M value. So M value is nothing but 528 by 23. So roughly it is a 24, I guess. So now what is the meaning of this 24? So once you got your M value is equal to 24, M is equal to 24 means I can able to maintain 24 block pointers, 24 block pointers in a single block, which means you take a one block which is of 512 bytes, observe carefully, which is of 512 bytes, I can able to sustain, you see that dot 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 to 24 pointers I can able to maintain. Therefore, you can able to maintain maximum of M minus 1 keys. So how many keys I can able to keep? At maximum 23 keys I can able. So my dear friends, you observe carefully how many records I can able to place up to at particular level. I say level 1 dash keys you can insert. It's a simple. How many keys I can insert? 23 keys I can insert. Level 2, how many keys I can insert? I have given a equation in the last class. How many keys you can insert at level 2 and level 3? Simply you say that M of your L minus N. If it is a level 2, your M is a 23 and level 2 minus 1. This is your maximum keys. If it is a level 3 and 23 of level 3 minus 1, these are the maximum keys you can able to keep at level. That means the summation up to the level 3 is this much. Observe my dear friends carefully. This is how to find the maximum block factor or a maximum degree of your B tree. Now let us discuss B plus tree. So what is the main problem with the B tree? Please recollect last lecture. The problem with the B tree is in a block I have got a block pointer and also I have got a keys. So key 1 and its a block record pointer, key 2 and its record pointer. Therefore, if you are having a data file, then what is going to happen? The length of the record pointer to your data file is going to be vary. That means I'm going to have a data pointer from there to here. If I have a subtree, now what will happen? You please see that this is a key 3, you are having a 1, and if I am saying a key 4, you are having a one more record pointer. Therefore, you have a record pointer from internal node, you also have a record pointer from internal node. Therefore, length of your record pointers are not same to your root, because your data file is going to get the data pointers from all the levels. You're going to find from internal node as well as from your root node. So this problem can be eliminated with the help of B plus tree. If anybody asks you what is the difference between binary search tree and balanced search tree, binary search tree the maximum degree is only 2, and balanced search tree the maximum degree you can able to compute using that equation which I shown you. If anybody asks you what is the difference between B tree and B plus tree, B tree record pointers are available at all the levels of the tree, but B plus tree record pointers are available only to the leaf node only, because leaf node is obvious which is trying to get the data from your data file. So leaf node is going to consist a record pointer. The rest of your tree consists only block pointers and keys only. So only leaf node is involved in real time to pull your data from your data file. So my dear friends, this is the difference between your B plus tree and B tree. That's why B tree needs 2 orders. Understand carefully. B tree needs 2 orders. B plus tree needs 2 orders. What are the 2 orders? One order for a root and internal node, and another order is for a leaf node. But in B tree, you are having only one order which is equal to all your nodes. It may be a root, it may be internal node, it may be a leaf node, because the structure everywhere it is the same. But B plus tree, as I am maintaining a 2 orders, one is for root and internal node and one is for leaf node. So you're going to see that the structure of leaf node is different from structure of root and internal node, because leaf node only maintains the record pointers. Root and internal node do not have record pointers. That's why your 2 different structures you need to learn. One for root and internal node, another one for a leaf. So let us look at some of the points. A B plus tree is a balanced tree. This is a very important point, previous GATE question. Path from the root to the tree to a leaf is of the same length. And each non-leaf node half full, so n by 2, complete full, m. Don't forget this, there and here same rule. Now, so half full is nothing but 50%. You know that complete full is nothing but 100%. So all data is stored in leaf node, which I already shared this point. What is that? Leaf nodes are responsible to get your data from your data file. That's why we are maintaining record pointers only at the leaf only. Observe, my dear friends. The structure of leaf node is different from structure of your non-leaf node, because you are going to maintain record pointers, whereas a root and internal node do not maintain record pointers. So all leaf nodes are the same depth in your B plus tree. The length of the paths from root to all leaf nodes are equal. An internal node is always half full and complete full. So all points are similar except 2. What is that? 2 orders you need to maintain. One order exclusively for leaf and another order exclusively for non-leaf. But in B tree, altogether you are having only one order. And the second difference is record pointers are available only at the leaf, but in B tree record pointers are available at all the levels of the tree. What are the advantages of a B plus tree? As there is no much overhead, it is eligible for larger file organizations with a less overhead. That's why it's a very fast searching. All leaf nodes are at the same level. B plus tree is the combination of B tree and indexed sequential access methods. So one more advantage, what is that? Your current RDBMSs, every RDBMS is a real-time application of your B plus tree. So B plus tree is a real-time application to your RDBMS. Right now we are using it. And what are the disadvantages? Insertion and deletions are expansive, and this is the what? Keys are duplicated. You need to maintain a duplicate keys, but whereas in B-tree duplicates are not allowed. Now I will show you the construction process of your B tree and B plus tree so that you will understand how to construct B plus tree. Let us say the keys are 10, 15, 1, 7, 8, 25. He is asking to construct B plus tree and B tree. So you want to construct B plus tree. As I said, you need two orders. One order is leaf node and another order is a non-leaf node. So two different equations. Because leaf node structure is different from your internal node and root node structure. So M1, what leaf node order is telling you? Leaf node order is telling you that maximum number of keys. Maximum number of keys is your M1. What M2 is saying? Maximum number of block pointer. This is a common in B tree and B plus tree. Maximum number of block pointers. This is a common factor, but whereas this is not there in your B tree. So M1 is exclusively for leaf node where you see that maximum number of keys. Now I am giving you, according to this problem, this is 2 and this is 3. What is 3? The P root or P internal node order is 3. P leaf order is equal to 2. What the P leaf is saying? Maximum number of keys. What the P root is saying? Maximum number of block pointers. So 3 is a maximum number of block pointers. So I can keep maximum number of keys in root and internal node is m minus 1. That is nothing but 2. This rule is a common. This rule is a common in B tree also. Same m block pointers, m minus 1 keys. But this particular rule is not there in B tree. It's exclusive. When I say m for leaf node, in the sense those many keys you can able to store. So now let us construct with the P leaf 2 and P root 3. So B plus tree, two orders are mentioned. P root 2 is equal to 3 and P leaf is equal to 2. You are having splits and all same rules as like your B tree only. The keys are mentioned 10, 15, 1, 7, 8, 25. Now let us start construct from your single level. Single level is nothing but myself is saying that it is your leaf. If it exceeds, then you start splitting, then you're going to get a concept of root. Otherwise, you're going to see that single level indexing only. Now, let us see that the P leaf, I can able to insert two keys. So what are the two keys I can able to insert? 10 and 15 I can able to insert. And every leaf is going to maintain, every key is going to maintain record pointer 10 dot, 15 dot. So two keys are inserted first. Then after that I am trying to insert one. When you are inserting 1, your block structure looks like this: 1 dot, 10 dot, 15 dot, because the keys are going to be kept in the form of a linear sorted order. It is greater than your P leaf, because a P leaf can able to keep only maximum 2 keys only. So therefore, what is required? The leaf is going to split. So this splitting can be two varieties. One is left biasing, left splitting. The other one right biasing, the right split. So any split you can use. Either you want to go for left split or right split. So let me take a right split for according to this example. So right split is nothing but greater than is equal to, left split is nothing but lesser than is equal to. Please understand, my dear friends, step by step you understand the construction process of your B plus tree. Now the middle element is going to as a root. Now the middle element is a 10. The middle element is a 10. So this we are going to call as a root. And you're having one key, two block pointers you're having. One is a left side tree and the other one right side subtree. Don't try to keep any kind of a block as a record pointer here, because a root and internal node do not maintain any kind of what? Record pointers. Leaf only is going to maintain record pointers. Therefore, you bring the remaining keys. I said I am doing a right split. When you are doing a right split, I need to follow greater than is equal to, less than and greater than is equal to. So less than, if you consider 1 and dot, and the right hand side greater than is equal to means this 10 you need to maintain, because the leaf is responsible to store your keys. That's why we need to write the 10 also, and one more is also there, that is a 15 dot. My dear friends, this is your leaf and this is your root. So root is going to maintain only block pointers and keys, and leaf is going to maintain leaves and record pointers and link pointer to link this block and this block. So this is called a link among the blocks, called as a link pointer, also called as a blocking among the two leaves. Let me number the now. This is your block number 1 and this is your block 2. This is your block 3. We want to show that block 2 and block 3 are the leaves which are of your block 1. Therefore, there is a requirement of a block pointer. Now let us see. I want to insert the next one, 7. So when you are inserting a 7, observe carefully. 7 is greater than 1. So I want to insert 7 now. Insert 7. So 7 is greater than 1. I am checking in leaf only. 7 is greater than 1 and less than 10. Otherwise 7 is less than 10. So it is going to position it here. Therefore, my dear friends, the 7 we are going to keep it here only. So as usually you are going to get 10 as your root, no doubt, I am not disturbing. And the left hand side lesser than figures are going to come. Already there is a one key, 1 dot, and recently one more key is coming, that is a 7 dot. No problem. I can able to keep, because your leaf order is equal to 2. I can keep 2 keys. So your P leaf, every time you need to check, P leaf is 2. 2 keys I can able to insert at max. Right hand side there is no disturbance. Exactly, I am writing 10 dot and 15 dot. Now you may observe carefully. This is a block 1. This is your block 2. Some change happened. This is your block 3. And as usually there is an interlinking pointer between these two leaves. Now you tell me, my dear friends, duplicates are allowed or not in B plus tree? Obviously, because the 10 I am maintaining in one of the block B1 and 10 I am also maintaining in one of the block B3. This is B2 and B3 are called as leaves, and your top B1 is called as a root block. This is your root block, and B2 and B3 are your leaf blocks. Now I want to insert 8. So when you want to insert 8, 8 is supposed to be inserted. Please look at carefully. 8 is a lesser than 10. Otherwise, 8 greater than 1 and greater than 7 and lesser than 10. So 8 is supposed to be inserted left hand side only. Therefore, if you look at your structure, there is a 10 and two 3 pointers here, 1 dot, 7 dot, 8 dot. So I am inserting 8 in this. Now right hand side there is no problem, 10 dot, 15 dot only. Here this particular block consists of 3 keys, which is greater than your P leaf, because your P leaf maximum only 2 keys only. Therefore there is a requirement of once again a splitting. As I am using a right splitting, so you need to consider in entire tree. So right splitting I am doing. Therefore, this middle element, that is the 7, is going to be entered into root. So therefore, 7 and 10. Now observe, there is a block pointer, and there is a block pointer, and there is a block pointer. Now you observe, here I am having lesser than is equal to, so sorry, less than, I am having a less than, and we are having greater than is equal to, and this is also we are having greater than is equal to according to that. So this is not disturbed, it is a 10 dot and 15 dot, but this one is a disturbed, which is separated. Please observe carefully, the greater than is equal to I am doing, right? So 7 dot, 8 dot, so which is separated, this one is separated. Now let us naming them. This is your root, block 1 is your root, and this is your block 2 is your leaf, block 3 is your leaf, block 4 is also your leaf, and leaves are being integrated with each other. There is a requirement of a what? A link pointer. This is going to be a null because I do not have any link. And now let us see, are they satisfying our constraints or not? Exactly. Your P leaf is equal to 2, so 2 keys are there, lesser than is equal to 2, no problem. Here also your P leaf is equal to 2, no problem, it is also satisfied. Here also your P leaf is equal to 2, it is also satisfied. What about P root 3? 3 means 3 block pointers, exactly, not problem and no problem and no problem. 3 block pointers, nothing but 3 trees you got, 3 subtrees, subtree 1, subtree 2 and subtree. Now let us insert one more key. What is that? After insertion of 8, I want to insert 25. Now you will see the difference. This time right hand side block is going to be under splitting, because 25 greater than 1, greater than 7, 8 and greater than 10 and greater than 15. So block 4 got some adjustment here. So let us see. 7, 10. And 3 block pointers. Block pointers are nothing but child pointers only. Here there is a 1 dot. Here there is a 7 dot, 8 dot. Here there is a 10 dot, 15 dot. Now I am inserting 25.2. I am inserting 25 now. Now what happened? This is a fine, no doubt. This is a fine, no doubt. But this is the problem. Why problem? This is greater than your P leaf. Because your P leaf maximum is only 2. Therefore, there is a requirement of split. As I am doing a right split, In entire tree, you need to follow right split. Don't change in middle. Now the middle element is going to enter into root. Observe, my dear friends, carefully. 15 is the middle element. Therefore, you got 7, 10, and 15. Observe carefully. Now you got 4 block pointers. This is against rules of your P root, because your P root and P internal node is given only 3, but you got 4 block pointers. So that means your 4 block pointers are greater than to your 3. Hence, there is a requirement of what? A root split is needed. A root split necessary, because, observe carefully, because 4 block pointers are available according to this, which is greater than to your P root. Now the root is going to start splitting. The middle element is going to up. So 10 is a main root to you. So 10 is your main root to you, which has got 2 block pointers. Left hand side, see that there is a one node called 7, and there is another node called 15. Now this is your internal node, and this is also your internal node, and this is your root node. Observe carefully, don't talk in favor of data structures. Please think in favor of DBMS only. This is your block 1. This is your block 2. This is your block 3. I will also show you the final shape. Now, this has got, observe carefully, internal node. What is your order? P root order only. So 3 block pointers I can keep. It's fine. So here also 3 block pointers I can maintain. It's also fine, because 2 block pointers only. Here also 2 block pointers, no problem. It is also fine, because I can keep maximum of 3 block pointers. Now you tell me. So this is how the keys are going to be given. There is a change in exactly at last node only. So our focus is on to last node. Please understand carefully. This is our focus. So as I am doing greater than is equal to, so 15 and 25 will go a right hand side. 15 dot and 25 dot goes to the right hand side, and this 10 is separated from there, because I am following lesser than and greater than is equal to. Now you see, here also greater than is equal to we want to solve, and this is your less than. So what are the keys are there? So 1 dot, 7 dot, 8 dot. So 1 dot and 7 dot, 8 dot. So observe carefully, this 7 is brought down as it is greater than is equal to. This 10 is brought down. This 15 is also brought down as it is greater than is equal to. Now you see that all the keys are completed, because our target is to insert those many keys. We already completed. So this is your final structure. Now I will show you the final structure. This is your block 1. This is your block 2. This is your block 3. These are internal nodes. An internal node and root node doesn't maintain any record pointers. Observe carefully. Now you see, this is your leaf node. The last level is your leaf. So now you observe carefully. This is your block 4. So I am labeling here. This is your block 4. This is your block 5. This is your block 6. This is your block 7. So 7 blocks I took. 7 blocks I took only for indexing only. Observe carefully. only for indexing I took 7 blocks. Now down there is a data file. This is your data file which consists of your keys. What are your keys? So 1 and 7 and 8 and 10, 15 and 25. Therefore, my dear friends, record pointers are available only at leaf node as I told you. Therefore, record pointer is eligible to retrieve your data. So record pointer is here, and record pointer is here, and record pointer is here. So record pointer is here, record pointer is here. If a user asks, I want to search record number 15. If a user asks, I want to search record number 15, it start first to search in root only. 15 is a greater than 10. So it is coming right side. 15 is equal to 15. Yes, it is satisfied. It goes here. And 15 got found in the leaf. I use the record pointer. Get your record. So this is how it is trying to perform the lookups to get back your data from your data file. So how many levels in your index? Index there are 3 levels. So level 1, level 2 and level 3. So 3 level index I computed. And what are the total number of levels to get back your record? 4 levels. 3 levels index and 1 level to jump to your data file to get back your record. Understood, my dear friends? So let me show you now horizontally so that you will understand very clearly. So your data file is at last consist of 178, 10, 15, 25. You may get a doubt why I have written in a sorted order. Why I have not written in a mixed order. Sorted order why I maintain? Because B plus tree and B trees are ordered index. Now this is your block 1 of your data. Now we computed block 1 for your root. What is your root? So 10. 10 is your root which has got two important fields, key and record pointer. Observe carefully. 10 dot. But here we are not maintaining any record pointers. So we are maintaining simply block pointer only. Therefore what will happen? It is a pointing that side, it is a pointing this side. Now block 2, there is a 7. There is a 7 and which has got two block pointers. And there is another node. So what is that node? It is a 15 and which also got two block pointers. So this is a block 2, this is a block 3. Now your leaf, so it comes to your leaf. Your leaf consists of 1 dot, 7 and 8 dot. So 1 dot, so 7 dot, 8 dot. And the next one is so 10 dot, 15 dot, 25 dot, 10 dot, and this block consists of two keys, 15 dot and 25 dot. We do not have any block pointers to your leaves. Observe, this is a block 4, this is a block 5 and the block 6 and your block 7. Leaf can store maximum two keys. Here I can accommodate one more. Here I can accommodate one more, no doubt. So use the record pointer to get back your record. So record pointers are playing a crucial role to get back your record like this. So this is how exactly RDBMS looks like. Earlier, I shown you, observe carefully. This is your data structure, how you might have learned. But now, this one is your exactly RDBMS B plus tree structure. So your B plus tree, according to your RDBMS, looks like this. So this is your root, is a contacting to your internal node. Internal node is nothing but please talk like internal block only, root block and internal block. And this is contacting your leaf blocks. They are your leaf blocks only. And leaf blocks is ultimate to get back your data from your data pointer. And one more I said, these blocks are integrated each other. So there is a mandatory, this important point. So this is your complete B plus tree for a given 6 keys. They are 1, 7, 8, 10, 15, 25. Tell me, see, my dear friends, observe this is how you can compute the B plus tree. But I have performed only right splitting. You want left splitting, I will show you with the same keys in a quick manner. Observe carefully. Your keys are 1, 7, 8, 10, 15, 25. So your keys, you may insert them in a mixed order, but the B plus tree is going to convert them into proper order, no doubt. So 10, 15, 1, 7, 8, 25. 10, 15, 1, 7, 8, 25. This is how users send the data. But anyhow, B tree and B plus tree, as they are ordered trees, automatically the keys are going to be in linear mode, shuffled. Now let me do this time left split. Observe carefully. So the left split is nothing but lesser than is equal to. And you also need to provide two important things. What is your P leaf order and what is your P root order? Same I have taken. So two keys at a time I can able to insert. Because initially I am starting with a single level indexing which is nothing but leaf. So now the first two keys are 10 and 15. No doubt. Same like the previous. Now you see, I want to insert 1. Whenever you insert 1 into here, then it is exceeding your P leaf because your P leaf only can consist a maximum of 2 keys. So 1, 10, 15, it's greater than to your P leaf. Therefore, there is a requirement of split number 1. The leaf split number 1 is happening. So middle element goes up, that is a 10. Now we are going to call it as a root as it is a split. Now left hand side you are having a less than is equal to, which means 1 dot 10 dot. And right hand side you are having greater than only, observe carefully, 15 dot. So I am doing left biasing now. Now you want to insert a 7 into that. So you can quickly insert here only. But I am saying is 7. So 7 is a greater than 1 and lesser than 10. So I need to insert at the left hand node only. So therefore, you see that a 10 is here, which consists of 2 block pointers. So already 1 is there, and recently I am inserting one more value, that is a 7, and 10 is also there. 1, 7, 10, and right hand side 15 is there. So no modification at the 15 side because it is lesser than is equal to your P leaf. This is greater than to your P leaf because 2 keys you are eligible but 3 keys are coming. Therefore, once again, leaf is going to undersplit. So this 7 is going to top. So now the 7 and 10 will come here. Now as usually, 2 keys means 3 pointers you are going to get in your root. So this is your root. You need to follow lesser than is equal to. So what is your less than is equal to? Up to 7 you need to write 1 dot 7 dot, and middle is a separated 10 dot, and this is as usually 15 dot. So it's fantastic. And now you see that this is a fixed because two keys are there. Still I can accommodate one in this. Still I can accommodate one in this. Now I want to insert the next element, that is called 8 and 25. Let me insert 8. So 8 is greater than 1, greater than 7, and lesser than 10. So I can able to accommodate here. So you can happily insert 8. So insertion of 8. This is your block 1. This is your block 2. This is your block 3. This is your block 4. So insertion of 8 is done at block 3 only. No doubt, because I can send 2 keys into that. Now I want to insert 25. Observe, my dear friends. 25, where are you going to insert? Now insertion of 25. So 25 greater than 1, greater than 7, greater than 8, greater than 10, greater than 15, and there is accommodation here. There is a space. So I can keep it in the simply block 4. So therefore you got here. If you do the right split, you got 3 levels. If you do the left split, you got 2 levels. Observe, my dear friends, be careful. This is one of your gate question. I did according to the right split. I got 3 levels. This is your level 1, and this is your level 2, and this is your level 3. But if I am doing a left split, I have got only 2 levels. All keys are accommodated perfectly without any gap. That's why you see that minimum number of splits left split is giving, maximum number of splits right split is giving. You need to decide which split is going to give you minimum and maximum. So my dear friends, the final structure is after doing left biasing. So this is your final structure. So it is 1 dot 7 dot. This is a 10 dot, 8 dot, 10 dot, and this is a 15 dot and 25 dot. Bus. So how many blocks you took? Very limited number of blocks I took. This is your block 1, this is your block 2, and block 3 and block 4. But earlier I took how many blocks? Observe carefully. I took almost all 7 blocks. Block 5, block 6, block 7. This is so dangerous. Whenever you are increasing number of splits, then automatically blocks are going to be allocated. Wastage of space for us. You decide which one is going to give you minimum split, left split or right split. So down you are having a data file. The data file looks like your leaf node only. Whatever the keys are there on your leaf, your data file is also going to have. So 1 and 7 and 8 and 10 and 15 and 25. If you are able to keep all your data records in a single block, you can keep. Otherwise, you want to merge into double block according to your block factor, you can do it. I am taking directly one block only. So record pointers are eligible only from your leaf node only, not from your internal node and not from your root node. And this is interlinking to each other. This is going to be null. If I construct the same for your B tree, what will happen and how it looks like? This is your leaf. Record pointers are available, so I am highlighting them. Record pointers are only available at your leaf, not at internal node and the root node. And one more important point I said, B tree record pointers are available everywhere. Let us construct. So B tree I am forming with the same, only one order is sufficient for B tree because the structure of leaf and others are same. I am taking order is equal to 3. Now what are your keys? 10, 15, 1, 7, 8, 25. So let us start insert 3 pointers means 2 keys I can able to insert. So 10 dot, 15 dot, here you need to maintain record pointers are also. And 2 keys I have inserted. Now I want to insert 1. When you insert 1, same thing is going to happen. When you insert 1, it becomes 10, 1, 10 and 15 which is greater than your p root. Because you are going to get a 4 block pointers, 3 keys means. That's why immediately you need to separate them. So middle element goes up. And now 10, which has got left node, which has got right node, and dot record pointer you need to maintain because record pointers are available at every level. Now here you are going to see the 1 is separated, and here you're going to see 15 is separated. That is not like its construction is different from your B plus tree. Now I want to insert 7. I can insert 7 here. Now I want to insert 8. 8 I can insert here. As soon as enter your 8, it is greater than your 3. Hence therefore there is a need of a split. When you split, 7 goes towards the up. Now 7 and 10 it looks like. As the 2 keys have come, there is a requirement of separator. 7 dot, 10 dot. So left hand side you are having, observe carefully. So what are you are going to have at left hand side? And what are you going to have at right hand side? So your right hand side is as usually is a 15, and the left hand side you are having a 1 because 7 is already move up, and middle you are going to have a concept called 8. Now I want to insert 25. So 25 you can push into this. So this is how you can able to do the concept of a B tree simply. Now down you are having a data file. Your data file has got the records. How it has got the records? It has got 1 dot, 7 dot, 8 dot, 10 and 15 and 25. Dots are not there. So now let's see, this is retrieving, and 7 is retrieving from root, 8 is retrieving from leaf, 10 is retrieving from root, and 15 is retrieving from leaf, 25 is. So what do we understand? Record pointers are available at every level of the tree. You want to search a record, you have to search from root and as well as internal node. Use the pointer, get your record. That's why B tree structure is M block pointers and M minus 1 keys and plus M minus 1 record pointers are available in your particular block. All the 3 you need to insert in a block. See that? Block pointers you are having, record pointers are also you are having, and keys are also you are having. But whereas if you look at the B plus tree architecture, see the beauty of this. What is that? Your root node is different from your leaf node. The root node consists, please observe carefully. A root node consists, what are the elements? Consist of keys and consist of block pointers. How many block pointers? M block pointers. And how many keys I can able to keep? M minus 1 keys I can able to keep. They are in your block. No other element is there in your root and internal node. That's why internal node structure and root node structure is the same. But if you look at the leaf, what your leaf consists? Leaf consists of different elements. I am maintaining a keys and I am also maintaining record pointers. M keys, P leaf keys you can insert, and m record pointers are also you are maintaining, and plus one link pointer I am maintaining. This is your link pointer. So one block pointer I am maintaining, and all the three are available in your block. My dear friends, we got two equations. One equation for a leaf node and the other equation for a non-leaf node. Please observe carefully. This is your non-leaf node structure. What is that? If you take a block, a database index block, if you take, this block consists of block pointers and keys. So that's what. So n block pointers, n minus 1 keys, they are available in your block. Now if you are looking at a leaf node structure, so what is your leaf node structure? I shown you leaf node has got three elements. What are the three elements? Observe carefully. I am maintaining a keys, and I am maintaining a record pointer, and I am also maintaining a what? A link pointer. So n keys and n record pointers and one block pointer. So here n is nothing but order of 3 only, like p leaf and p root. So according to that, you can able to design what is the order of your p leaf and what is the order of your p node or p internal node. So let me give you one example before going to this. Block size is equal to 512 bytes. Very, very important questions. Without these questions, the gate paper is not going to be. And record pointer is equal to 9 bytes. Key size is equal to 7 bytes. And block pointer is equal to 6 bytes. He is asking three questions. Find the order of B tree. First question. Order of B tree. M block pointers, all three you are having M block pointers, M minus 1 keys, and M minus 1 record pointers. This is your B tree structure. They are all available in your block, which can be lesser than is equal to. Now block size is a 512 bytes is mentioned, and M block pointer 6 byte is mentioned, and M minus 1 keys, key size is a 7 byte is mentioned, and M minus 1 record pointer, which is mentioned 9 bytes. So convert them into numerical. So this is a 7M minus 7 plus 9M minus 9 is equal to 512. So 15 plus 9, 24M is equal to 528, which is M is equal to 528 by 24. This is your B tree. One order is for all the nodes, a root and internal node and leaf node. The same question we want to do for B plus tree. Find order of B plus tree. So you can find for two. One is for non-leaf node and the other one for leaf node, because we are having a two structures. Non-leaf node is nothing but M block pointers plus M minus 1 keys is lesser than is equal to your block, and leaf node is M keys plus M record pointer plus one block pointer is in your block. So let us say a block pointer size is given 6 bytes, and M minus 1 key size is given 7 bytes. And block size is given 512. Now 6 plus 7m minus 7 is equal to 512. So this is 6m plus 7m, 13m is equal to 519. So m is equal to 519 by 13. And here also m keys. So key size is 7 bytes. And m record pointer 9 bytes. And one block pointer 6 bytes. Lesser than is equal to 512 bytes. Now this is m7 plus m9 plus 6 is equal to 512. So it is a 16m is equal to 506. That is equal to m is equal to 506 by 16. That's it, my dear friends. This is how to compute order of your non-leaf node and order of your leaf node, especially in B plus tree. In B tree, there is only one order, so this is your answer. So once you find the order, what are you going to achieve? If I am saying that B tree order is equal to 26, what is the meaning? 26 maximum of 26 block pointers. Very important questions, my dear friends. This is, that means maximum of 25 keys in a block. Single block can consist this much. And minimum equation, you know. What is the minimum equation? 26 by 2. Minimum of 26 by 2 block pointers. And minimum of 26 by 2 minus 1 keys. This is about B tree. If I am saying that B plus tree 2 orders, what is the meaning of that? B plus tree leaf order, if I am saying, means leaf order is equal to 26, I say. What is the meaning of 26? 26 keys in a block, maximum. Minimum, you know. This is in a single block, you can able to store this much according to leaf. Because B plus tree is also having another order, that is a non-leaf. If I am saying non-leaf is 26, which is very similar to B tree only. What is that? Same story. 26 maximum block pointers. 26 maximum block pointers. And 25 keys. And minimum also, you know, same. Half you need to do. This is the difference between B tree and B plus tree. So what are the differences? The difference between your B tree and B plus tree, only two, nothing else. In B plus tree, all pointers are available only at leaf. But B tree, data record pointers are available at every level. This is the one difference. Because of this, a B tree can have lesser number of splits and lesser number of levels in B plus tree. In B tree, you are having a more number of levels. And the next one, in B tree, every value of the search field appears only what? That means no duplicates are allowed. But duplicates are allowed in B plus tree. So no duplicates in B tree, but duplicates are available in B plus tree because the keys are multiple available. One is available at leaf, One is available either at root or internal node. But in B tree, only key is available either at root or leaf or internal node. So, my dear friends, this is what about the concept of B plus tree and B tree. So let us construct quickly your B plus tree. You also can try. I'm giving you the P root is equal to 3 and P leaf is equal to 2. You can tell me how many splits you are going to get. So he is asking maximum number of splits. Not less, I don't. I want maximum number of splits. This is one of your previous gate question. That means you need to do a left biasing and you also need to do a right biasing and see that how many splits you are going to get after insertion these 3 plus 3, 6 and 2, 8 elements. 8 keys you are inserting. You tell me how many number of splits, more number of splits. If left split you got 3 and right split you got 4, 4 is your only your answer because he is asking maximum number of splits I need. So do it left split less than is equal to and right split is nothing but greater than is equal to. I will tell you shortcut which split is going to give you more number of splits than others in tomorrow's session. My dear friends, stay tuned to Unacademy and stay tuned to Srinivasrao Sir classes, especially database, computer networks and operating system. And my dear friends, so from 10th October onwards, I'm going to start computer networks full length course. Computer networks full length course on YouTube. So don't miss this opportunity which is providing by Unacademy. So timings I'm going to announce very soon. This is likely tentatively from 10th October. Utilize this opportunity. Complete computer networks I'm going to place in your Unacademy YouTube channel. Let's crack GATE ESE. So it is going to start from basics to advanced till cryptography, network security. I'm going to cover. That's why I'm going in a one by one in a linear order fashion. Therefore, the current third year students can learn the computer networks very well, and passed out students also you see that you are having a good grip on basics after learning this computer networks. Full length course, it is available on YouTube free of cost. Okay, my dear friends, this tentatively likely may be started from 10th October. So tomorrow our schedule is practice session on B tree and B plus tree. So how to construct them as well as how to find the orders of B tree and B plus tree. This is our tomorrow schedule which is at 8 p.m. So 7th October schedule is this, and as I told you 10th October onwards you are going to have a computer networks full length course according to your GATE curriculum. So my dear friends, you want to much more still depth knowledge in other subjects also, please use my referral code and get the admission into an academy. And once you use this referral code, you are going to get a maximized discount benefit. Please use this opportunity and please do like all my lectures because so much pain we are taking apart from regular activities because content and other things. Please give a like and share this knowledge to all your friends. Thank you very much. We will meet in tomorrow's session and please advertise this to all your friends that whoever is interested in computer networks from basics to advanced that I'm going to cover you from 10th October. So this computer networks I'm going to cover from few textbooks like Cruz and Ross, all textbook knowledge you are having. Then Tannenbaum, and then Williams Stallings, and one more that is called Peterson. So 4 textbooks and knowledge you are going to get from 10th October. Please be ready and please join into Unacademy to have much more lectures from me in other subjects also. Use my referral code. Thank you very much, friends, for staying much time. And also, please like my lecture. Join in Unacademy. Stay tuned to Unacademy channels. Please do admission in Unacademy. Thank you very much. So, my dear friends, so this is an offer to you, computer networks classes. Please don't miss from basics. So, three parts I am going to divide your computer networks: basic and middle and advanced. Basic is physical layer and data link layer. Middle means internet layer, and advanced means IP addressing and transport layer and cryptography and network security. So thank you very much, friends, for supporting to me and encouraging to me. And you all creditful to Unacademy. Without Unacademy, you and me are not there. Please subscribe Unacademy YouTube channel. Also, please give your admission so that you are going to get many kinds of things like this. Thank you very much. And I gave you task. Please do this task and tell me maximum number of splits. So I will give you a shortcut. You need not do left split and right split both times. I will give you a shortcut. With the shortcut, you can able to see that which is going to give you more number of splits. Thank you very much.